Good day, everyone. Hello. Anyways, I am Lubu Margelincy, and today I will be discussing with you about chain rule and the rule of trigonometric functions. And let's try to use them. Let's try to answer a problem using this too. So, chain rule is used for differentiating composite function. When we say composite function, it is a function inside another function. So this is the general form of a composite function. We have f of g of x. Okay? So the derivative of this composite function is this one. As you can see, we have here the derivative of f of g of x is equal to f prime times g x multiplied by g prime times x. So, this chain rule is applicable only for algebraic and trigonometric functions. Now, what is trigonometric functions? The example of trigonometric function is this. We have here y is equal to sine multiplied by 3x squared and y is equal to cos 5x plus 2. Trigonometric functions like we have sine, cosine, theta, cos theta, sec, like that. Now, the formula in getting the trigonometric function is this one. When we have d over dx multiplied by cos u, it is equal to negative sine u multiplied by the prime of u, or the derivative of u. And if we have sine u, the derivative of it is cos u multiplied by the derivative of u, or u prime. So let's try to answer a problem using this one. So we have here complex number 1. This is for algebraic function. So our problem, we need to differentiate the y is equal to the quantity square root of 6 times the quantity of 4x3 minus 5x squared plus 7x minus 2. So our u here is the inner function, which is the inside the bracket, or the braces, or the open and close parentheses. That is our inner function. While our outer function is y is equal to u6. Alright, so now let's solve this applying the chain rule. So the chain rule is equal to d over dx multiplied by y. It is equal to 6 u raised to the power of 5 multiplied by d over dxu. Because as I've said here, this is the formula in getting the chain rule of a function. Okay? So, yes. The first thing that we need to do here is we need to bring down the exponent 6 and multiplied 6 by 6 subtracted to 1. Our exponent 6 must be subtracted to 1. That's why we have here 6u raised to the power of 5, and let's multiply this by the derivative of u. That's why we come up here with an answer 6 multiplied by the quantity of 4x cubed raised to the minus 5x2 plus 7x minus 2 raised to the power of 5, and multiply this by the let's multiply this by the derivative of u. Now the derivative of this 4x cubed and so on is 12x squared minus 10x plus 7. Because again, you just need to remember the exponent rule. Alright? You just need to remember the exponent or power rule, which is y prime is equal to nx raised to the power of n minus 1. Okay. So, the derivative of our u is 12x squared minus 10x plus 7. So, our final answer of this complex problem 1 is equal to dy over dx is equal to 6 multiplied by the quantity of 4x squared minus 5x squared plus 5x squared plus 7x minus 2 raised to the power of 5 multiplied by 12x squared minus 10x plus 7. Okay, so that is for complex number 1. Now, let's try a little problem that is a little bit harder. Now, let's integrate algebraic plus trigonometric function. This is our complex number 2. Now, we need to differentiate this one. Y is equal to the quantity of 2x squared plus 3 sine x raised to the power of 5. Now, this is our u. Our u is again inside the open and close parentheses, or inside this quantity. This is our inner function, while our outer function is y is equal to u raised to the power of 5. Now, in solving this problem, we again need to use the chain rule. Now, while applying the chain rule, we come up with our final answer. Now, that's why we have here dy over dx is equal to 5 multiplied by 2x squared plus 3 sine x raised to the power of 4 multiplied by the quantity of 4x plus 3 cos x. Again, you just need to identify what is your inner and what is your outer function in that specific problem. After getting the inner and outer function, you just need to differentiate the inner and outer function, and after differentiating the outer function, you just need to multiply this into the derivative of your inner function. So that is for algebraic and trigonometric function. Now, why not try another complex problem? So we have here trigonometric multiplied by algebraic function. Now, this is our problem here. We need to differentiate the y is equal to x squared plus 1 raised to the power of 3 multiplied by cos 2x. Now, our u here is the first item, which is cube root of x squared plus 1, and our v is the cos 2x. Now, let's use the product rule. Again, the product rule is this: dy over dx is equal to u prime v plus uv prime. Okay, the derivative of u multiplied by v plus u multiplied by the derivative of our v. So, let's differentiate this problem. Now, we have here dy over dx is equal to 3. Again, the exponent, let's bring down the exponent and copy the u and subtract the exponent by 1, okay? That's why we come up this answer. Now, why is there 2x there? Because again, the derivative of the inside function is 2x. Alright, because you just need to bring down the 2 and copy the x. And 1 is constant, that's why it is 0. And after this 1, you just need to multiply this in our v, which is, we need to copy the v, cos 2x. And add. Remember that when multiplying, when using the, what do you call this one? When multiplying, you need to remember the operation addition. But when you divide something, you need to apply the subtraction. Because we are multiplying this item, we need to use the addition sign. Yes. And after this one, we just need to copy our u and multiply this by the derivative of v. Now, the derivative of cos 2x is equal to negative sine 2x multiplied by 2. So, you just need to get the product of these items. That's why we have here 6x times the quantity of x squared plus 1 raised to the power of 2 cos 2x. You just need to multiply 2x to 3. That's why we come up here with 3x. Copy it, and the same thing goes to the other part. Multiplied by 2 to negative sine 2x, that's why we come up with negative 2 sine 2x. Now, in this complex problem, our final answer is dy over dx is equal to 6x multiplied by the quantity of x squared plus 1 raised to the power of 2 cos 2x minus 2 times x squared plus 1 raised to the power of 3 and sine 2x. So that is how we solve the trigonometric and multiplied by algebraic function. Now, Mom Normina just told us to provide at least 3 complex problems, but I am convinced to add 1 complex problem. That's why I came up with trigonometric multiplied by algebraic function. Now our problem here, I only made this problem. Now our problem here is to y is equal to sine 3x over x squared plus 1 raised to the power of 2. Now we need to differentiate this one. Now in differentiating this specific problem, we need to apply the quotient rule. Now the quotient rule is dy over dx is equal to u prime multiplied by v minus, again, when you divide something, you need to use the subtraction sign, okay? You need to subtract this into u and the derivative of v over v squared. Now, in applying the quotient rule, we come up with this answer. We have here dy over dx is equal to 3 cos 3x multiplied by the quantity of x squared plus 1 raised to the power of 2 minus sine 3x multiplied by 4x x squared plus 1 over x squared plus 1, 4, because again, it is 2, but our formula for quotient rule is v squared. That's why 2 times 2 is equal to 4. Now, in this item, we can factor x squared plus 1 because in the left side, we have there x squared plus 1, and in this right side, we have here 4x x squared plus 1. That's why we can factor out x squared plus 1. Now, this is optional. This is the simplified final answer. Again, when your answer is this, it's okay. But when you want to be more specific, you can factor this out. Now, in factoring out x squared plus 1, you just need to let the x squared plus 1 outside of your bracket and copy the item. That's why we have here x squared plus 1 multiplied by the 3 cos x times 3x, x squared plus 1 minus 4x sine 3x over x squared plus 1 times x squared plus 1 raised to the power of 3. Okay, we just need to cancel both of this x squared plus 1, and now our final answer for this complex problem is equal to dy over dx is equal to 3 cos 3x x squared plus 1 minus 4x sine multiplied by 3x over x squared plus 1 raised to the power of 3. Okay, so that is all for my discussion. I hope that you will learn something. So for chain rule, you just need first to identify the outer and your inner function, and after identifying your inner and outer function, you just need to differentiate first the outer function and keep the inside function unchanged, and you need to multiply this by the derivative of your inner function. After that one, you just need to multiply them and come up with your final answer. Always remember to apply the power rule, the derivative of basic trig functions like sine x is equal to cos x is equal to negative sine x, and when you have x, it is 1, and the constant will become 0. And you just need to apply constant rule and constant multiple rule, sum and difference rule, product rule, quotient rule, any rule. So yeah, that is how you do chain rule using algebraic and trigonometric functions. So that's all for my discussion. I hope that you learned something. Thank you for listening, and God bless. Bye-bye.